Hello student, in this lecture I will discuss about frequency domain specification like resonant peak, resonant frequency and bandwidth. Okay, so let's start our discussion. So see here we consider the transfer function of the second order closed loop control system like Ts equal to Cs by Rs equal to omega n square divided by s square plus 2 zeta. Here zeta is identified by del. Okay, so this is only zeta, nothing. So this is only zeta. So second order closed loop transfer function is Ts equal to Cs by Rs and this equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay, now we put here s equal to j omega in this expression. Okay, so if we put s equal to j omega, then our equation will be t j omega. Here we put s equal to j omega, that's why Ts equal to t j omega and this equal to omega n square divided by j omega whole square plus 2 zeta omega n into j omega plus omega n square. Okay, now we simplify this equation. So after simplifying this equation, tj omega equal to omega n square divided by, here we put the value of j square value is -1, that's why this is minus omega square plus 2j zeta omega into omega n plus omega n square. Okay, now here in this part we take omega n square common, that's why the equation, that means transfer function tj omega equal to omega n square divided by omega n square into 1 minus omega square divided by omega n square plus 2j zeta omega divided by omega n. Okay, so after simplifying this equation, now equation will be like this: tj omega equal to 1 divided by 1 minus omega square divided by omega n square plus j into 2 zeta omega divided by omega n. Okay, now let omega by omega n equal to u. Now see here we put omega by omega n equal to u and substitute this value in this equation. Substitute this value in this equation. Okay, so see, after substituting omega by omega n equal to u, our equation will be t j omega equal to 1 divided by 1 minus u square plus j into 2 zeta u. Okay, now from this equation we can write our magnitude, that means magnitude of our transfer function tj omega is, magnitude is defined by m and this m equal to mod of tj omega and this equal to root under 1 by root under 1 minus u square whole square plus 2 zeta u whole square. Okay, and phase of tj omega, that means phase of our transfer function is angle of tj omega and this equal to minus tan inverse 2 zeta u divided by 1 minus u square. Okay, now see what is resonant frequency. So resonant frequency is the frequency at which the magnitude of the frequency response has peak value for the first time. Okay, so resonance frequency at that frequency at which the magnitude of the frequency response has peak value for the first time, and it is denoted by, resonant frequency is denoted by omega suffix r. So see, at omega equal to omega r, the first derivative of magnitude of tj omega is 0. So differentiate magnitude, that means m, with respect to u. So if we differentiate magnitude with respect to u, then our equation will be like this. So from this equation here, so this in this equation we put u equal to ur and put differentiation, that means dm divided by du equal to 0 in this equation. Okay, in this equation here we put u equal to ur and dm by du equal to 0. So if we put u equal to ur and dm by du equal to 0, then we can find our ur equal to root under 1 minus 2 zeta square. Okay, now we substitute ur. U basically, what is u? U is omega by omega n, that's why ur equal to omega r divided by omega n. So here again we put the value of ur. So ur is nothing but omega r by omega n. So here in this equation, put the value of ur. So after putting the value of ur in this equation, we get omega r equal to omega n root under 1 minus 2 zeta square. So in this way we can find resonant frequency. So resonant frequency is basically omega r equal to omega n divided by 1 root under 1 minus 2 zeta square. So what is resonant frequency? So it is the frequency at which the magnitude of the frequency response has peak value for the first time. Okay, and this resonant frequency is mentioned or defined by omega suffix r. Okay, now see resonant peak. Okay, so what is resonant peak? So resonant peak is the peak value of the magnitude of Tj omega. Peak value means maximum value of the magnitude of Tj omega. Okay, and this resonant peak is denoted by m suffix r. Okay, so now here again we put u equal to ur and the magnitude, therefore the magnitude Tj omega is mr, m suffix r equal to 1 by root under 1 minus ur square whole square plus 2 zeta ur whole square. Okay, now here we put ur equal to, we know ur equal to root under 1 minus 2 zeta square. Okay, so here we put ur equal to root under 1 minus 2 zeta square and 1 minus ur square equal to 2 zeta square. Okay, so if we put ur and 1 minus ur square in mr equation, that means resonant peak equation, then our resonant peak mr is equal to 1 divided by 2 zeta root under 1 minus zeta square. Okay, so see here. Okay, so resonant peak in frequency response corresponds to the peak overshoot in the time domain transient response for certain values of damping ratio zeta. Okay, so the resonant peak and peak overshoot are correlated to each other. Okay, now see bandwidth. What is bandwidth? So see, it is the range of frequency over which the magnitude of Tj omega drops to 70.7% from its zero frequency value. Okay, so what is the bandwidth? Bandwidth is the range of frequencies over which the magnitude of Tj omega drops to 70.7% from its zero frequency value. Okay, clear? So at omega equal to 0, the value of u will be 0. Now substitute u equal to 0 in our m. Okay, so if we put the u equal to 0 in equation m, then our m is equal to 1. Therefore the magnitude Tj omega is 1 at omega equal to 0. Okay, so at omega equal to 0, the magnitude of Tj omega is 1. Now see, at 3 dB frequency, the magnitude of Tj omega will be 70.7% of magnitude of Tj omega at omega equal to 0. That means at omega equal to omega b, m equal to 0.707 into 1. That means this is equal to 1 by root 2. Okay. So magnitude m equal to 1 by root 2, and this 1 by root 2 equal to 1 divided by root under 1 minus ub square whole square plus 2 zeta ub whole square. So see, here we put ub square equal to x. So if we put ub square equal to x, then our equation will be 2 equal to 1 minus x whole square plus 2 zeta whole square into x. So simplifying this equation, we can find x equal to minus 4 zeta square minus 2 plus minus root under 4 zeta square minus 2 whole square plus 4, this whole divided by 2. Now we consider only the positive value of x. Now we consider the positive value of x, that's why x equal to 1 minus 2 zeta square plus root under 2 zeta square minus 1 whole square plus 1. So after simplifying this equation, we can write x equal to 1 minus 2 zeta square plus root under 2 minus 4 zeta square plus 4 zeta to the power 4. Okay. Now we again substitute the value of x. So x is nothing but ub square. Okay. X is nothing but ub square, and now put the value of ub. So after putting the value of ub, then our ub square equal to omega b square divided by omega n square. Okay. So see here, we see x equal to 1 minus 2 zeta square plus root under 2 minus 4 zeta square plus 4 zeta to the power 4. Okay. So from this equation, we can write omega b square divided by omega n square equal to 1 minus 2 zeta square plus root under 2 minus 4 zeta square plus 4 zeta to the power 4. Okay. So from this equation, we can say omega b equal to this omega n root under 1 minus 2 zeta square plus root under 2 minus 4 zeta square plus 4 zeta to the power 4. Okay. So in this way, we can define the bandwidth. Okay. So bandwidth omega b in the frequency response is inversely proportional to the rise time Tr in time domain transient response. So what is the bandwidth? Bandwidth omega b in the frequency response is inversely proportional to the rise time Tr in the time domain transient response. Okay. So see, in this lecture, I will discuss the frequency domain specification. Basically, I will discuss the resonant frequency, then resonant peak and bandwidth. Okay. So the rest part of our frequency response analysis I will discuss in the next lecture. Okay. Thank you.